Assalamualaikum and hi everyone. We are from Group N4 CS2483B2 and today we would like to present our project entitled Analysis of Annual Live Births in Negeri Sembilan, Malaysia. Before we begin, let us introduce our group members. Our team consists of 4 members which are Cik Nur Ain Syafiqah, Jasmira Ayuni, Nur Ainati Syahira and Siti Nur Khadijah Afifah. Now, let's move to the introduction of our study. A live birth refers to a baby born with signs of life even if only briefly after delivery. In Malaysia, live birth data is officially collected through the birth registration process by the Department of Statistics Malaysia. Based on the statistics released in 2024, the number of live births in Malaysia showed a decrease compared to the previous year. This decline also affected the crude birth rate per population. Because of this issue, we were interested in analysing the pattern and trend of birth rates over time, specifically in Negeri Sembilan, Malaysia. Next, this table shows the dataset used in our study. The data consists of the year represented by X and the crude birth rate represented by Y. For this video presentation, we chose to explain our findings between years and crude birth rate using cubic model. After obtaining the least square solution, we are able to calculate the error vector to determine the difference between the actual values and the predicted values. Then, we can calculate the magnitude of error to evaluate the accuracy and effectiveness of this model.
For the model implementation, we use the metric representation MV equals to Y. To solve our system, we have metric M on the left is our variable metric, built specifically for a cubic model. We have vector V contains our 4 unknown cubic coefficient which is A, B, C and D, and we have vector Y on the right is our actual output data.
So now, I will explain the least square solution used to obtain the best fit curve from the given data. First, we use the least square formula, which is V equal to the inverse of M transpose M times M transpose Y. So for the first step, we calculate M transpose M. This matrix is obtained by multiplying the transpose of matrix M with the matrix M itself. The values shown in the matrix come from the X value in the datasets. After obtaining M transpose M, we calculate its inverse written as open bracket M transpose M close bracket to the power of -1. This inverse matrix is important because it helps us solve the system and find the coefficient for the cubic model. Next, we calculate M transpose Y. This matrix is formed using both the X value and Y's value from the dataset. After that, we substitute all the matrices into the least square formula back just now. By multiplying these matrices together, we obtain the coefficient vector which is V equal to as shown in the slide. Therefore, the best fit linear curve is equal to 21.3120 minus 1.1432x plus 0.1014x squared minus 0.0030x cubed.
Next, we calculate the error vector using the formula error equals to Y minus MV. The error vector represents the difference between the observed data and the predicted values from our model. After obtaining the error vector, we calculate its magnitude, which is written as the magnitude of error. The magnitude error vector for our model is 1.2335. Since the value is relatively small, it shows that our model fits the data well and gives a reliable approximation. This graph compares the observed data with our best fit curve. The cyan points represent the actual data, while the red line represents the fitted curve. From the graph, we can see that the curve successfully follows the downward trend of the birth rate over the years, showing that our model is suitable for this analysis.
Moving on the graph of linear residual error, this plot is used to check our model accuracy. It measures the error or the distance between our real data points and the cubic curve. As you can see, the data points bounce randomly above and below the zero line without forming any distinct pattern. This lack of pattern is a good sign. It's confirmed that our cubic model is unbiased, highly reliable and provide an accurate fit for the data. The analysis and calculation. We compare our result across different models based on their error magnitude. Looking at the table on the left, the linear, quadratic and cubic model show the highest error at 2.47, 2.36 and 1.23. However, the higher model hits the absolute minimum error at 1.12. In conclusion, we can see by the best fit curve on the graph, the higher model provides the best approximation because it achieves the lowest error magnitude.
So, that's all from us. Thank you.